Hey everyone, so now we're going to go over some examples about scheduling with priority list. So when we schedule with priority list, we're trying to take our task and assign them to processors to get the processors to finish it in the most optimal time. So we're going to start with this example. It has 11 tasks, A through K, and it gives us the processing time of each task. We don't know which one has to be done before which other one. We're going to assume that we could just do any of them in any order. So a schedule with 3 processors, so n equals 3 processors, produces a finishing time of 30 hours. What is the total idle time for all the processors? So for this one, we're going to have to use our formula. We need to know that our total finishing time times our number of processors n is equal to our total idle time plus our total processing time. All right, so we're going to go over this vocabulary real quick and figure out which is which. So our finishing time, it gives it to us. So our finishing time is 30 hours. Our n is going to tell us how many processors we have. So with this one, n equals 3. So we're going to put 3 right here. Our total idle time is what we're looking for. It's asking us what is the total idle time. So idle time is how much time somebody's just sitting around doing nothing. And then our total processing time, so we're going to put a question mark right here. Total processing time is the amount of time it takes for all of the tasks added all up together to be completed. So we're going to take all of these and we're going to add these numbers together. When we add those up, we get 60 hours. So our total processing time is 60 hours. So what we're going to have is we're going to have 30 times 3 equals something, we'll leave it as a question mark right here, plus 60. So 30 times 3 gives us 90. So 90 equals 60 plus what? Okay, we can just do 90 minus 60 and figure out that our total idle time is going to be equal to 30 hours. So now we need to explain why a schedule with n equals 3 processors must have a finishing time of at least 20 hours. So to find the total processing or the finishing time, remember the finishing time is the total idle plus the total processing time times n is the finishing time times n. So what if we do it backwards? Let's assume we have no idle time at all. So if we have 0 idle time, let's use a different color here. So with 0 idle time, we're still going to have a total processing time of 60. So we'll keep the total processing time as 60. And we're going to say it's 0 idle. So whatever our finishing time is, and we're going to have times 3 processors. So our minimum, no matter what it is, has to be finishing time is greater than or equal to, if we divide by 3 here to get rid of that multiplication, divide by 3, we have 20. So finishing time has to be greater than or equal to 20. So the answer on this is going to ask us, let's see, the shortest critical path is a processing time of 20 hours. Well, we don't know that. The processors working without an idle time would take 20 hours. So what we did here is we got rid of the idle time. So this is correct. And then that means it takes 20 hours. So this is our answer right here. We don't even have to look at the other ones. So let's move on to an example where we're given the project diagram and the priority list, and we need to figure out what's the most optimal way of putting these tasks to our processors. So when we use the priority list method, we're going to start and assign based on what comes first in our priority list. So our priority list starts with C and then B, A, G, F, D, and E. So optimally, we want to do them in that order. So let's go ahead, and we have 2 processors, n equals 2, so we're going to have processor 1 and processor 2. So let's go ahead and draw it out. So the first thing we want to try to assign is C. So we need to figure out which ones are eligible and which ones are not eligible. So we're going to start here. Well, if we start, we don't have to do anything before we can start A. So we're going to circle A, we're going to circle B, and we're going to circle C. That means that these 3 right here are eligible. We can actually work on them. So we're going to move along our priority list. The first thing we want to assign is C is going to be given to our first processor. So we're going to take C and we're going to put a line through it because we're going to go ahead and assign C, which is 9 units long, to processor 1. That means when we put this notation of 1 line through it, that means it's been started. We're going to put 2 lines through it and kind of cross it out with an X once we finish that test. So let's move on. And now we've done C. Now we're going to look at B. So the next thing is B is 5. So we're going to assign B 5 right here. And that's going to be a little shorter than the first task of C. Well, we've started it, so we're going to go ahead and put a line through it. Now we're going to move along, we move along. Okay, now we finished B, so we can go ahead and cross that one out. Well, we finished B. Does that mean we can start E, or do we still have to finish C first? So we actually can't do E yet because we haven't finished C. So now what we're going to do is we're going to look, and processors 2 is ready to do something else. So our next on our priority list is A. Well, A is eligible, so we're going to give A, which is 8 units long, to processor 2. All right, we move along, we move along. Okay, now we finish C. So C is done. Well, now that C is done and B is done, we can circle E because E is now eligible. All the preceding tasks have been finished. So now that E is finished, we have a free processor, processor 1. Well, can we start on G? No, we can't start on G yet. Can we start on F? No, we can't start on F because that one's not ready yet. What about D? No, we haven't finished A. So the only one we have left to start is E. So we're going to go ahead and start E. So we're going to put 1 line through it because we're going to start it. We're going to put E, and E is, I think that was A, 6, yes. All right, E is 6 units long, so we add the 9 plus this, so it's going to be a little bit longer than the 8 over there. We're going to move along, and then we finish A. So processor 2 is done with job A. Now that job A is done, we can go ahead and circle D. That means D is ready. Processor 2 needs something to do. Well, we're going to move along our priority list. The only thing that's available for us to work on is D. So we're going to go ahead and give D right here, which is 12. Kind of scroll down there. And then we're going to move along. So this is going to be a long one right here. And once we move along, E is going to finish. The first processor is going to go ahead and finish E. So we cross that out and we're going to circle G. So we move along. Well, it's done. It needs to do something. Well, G is on our list, so we're going to go ahead and start G. We still haven't finished D because D's taken a long time. It's taken 12 units of time. All right, we're going to go, and we actually finished G before we even finished D. So we're going to go ahead and cross out G. All right, we have to keep moving, but can we do F yet? We have a free processor, but we can't do F. So we really can't do anything right now. We gotta kind of wait. So we're going to wait and go along. This right here is kind of free space. We're not doing anything here. And then processor 2 is going to finish. Wrong color. Finish with D. So we finish D. We can circle F. All right, we're going to assign F. It doesn't matter who we assign F to. Let's just say we're going to assign F to processor 1 because they're on the top. And then we start it, we finish it, when we're done, we can move on to the end and we're finished. So this is our end. But now we have a little bit of idle time right here. And this is a little bit not drawn to scale. Normally we're going to have a number line. So now let's look down here at our project timelines and see which one matches up. So we started with giving processor 1 C because of our priority list. So automatically we can see this right here is our correct answer. And as you can see, this little area right here is our idle time. While processor 1 finished E and G, we were still waiting on D to finish. We couldn't do anything there. And then only one processor could do F. And then once F was done, we were done with the whole project. All right. Now we're going to look at what is the project's finishing time. So the total finishing time for this project, you're going to look at where this falls on the number line, and it falls right there at 26. And our project's finishing time is going to be 26 units or 26 hours, whatever it's measured in. All right, now let's look at one more example because this is a little bit of a tricky thing to understand. We're going to try just reading our options and analyzing our graph based on the options. So we have the project diagram to the right, and we're going to circle the ones that are eligible. So A, B, and C are all eligible. Well, we're going to look at our priority list. So we want to start with A. So ideally, we're going to put A for one of our processors. And this time we have 3 processors. So we're going to take A, and somebody's going to have A. Okay, well, let's look at this. Well, that one has A, and this one has A. So we're just going to eliminate our answers instead of trying to go through and create the full thing. Next thing we're going to do, so A is 8 long. Well, we have 3 processors. We're going to do B because B is the next one. So we're going to start B, okay? Somebody has B here, and we're going to start C. So we're going to start C, somebody has C, and somebody has C. We're going to move along. All these numbers look right. Once we've finished, the first one we're going to finish is B, so we're going to cross that out. Now, let's look. This one right here, can we circle D? Can we go ahead and start D? Well, we can't because we haven't finished A. So we're going to have to not start D yet. We're going to have to wait until A or C finishes. So we're going to move along. In this example right here, they go ahead and start E. Can we start E if we haven't finished C? We broke the rules, right? So this one is an incorrect answer, so we know this one is our correct answer. And we can stop there and save us a little bit of time. Now we're going to look at the project's total finishing time. So if we've already have it listed out, we're going to just proceed with the full priority list scheduling, go all the way to the end. Once we finish everything, it looks like we are going to finish right here at 21 units of time. So our project's finishing time is going to be 21.